Okay, here's a bunch of data that I happened to run across. It's from the National Institute of Standards and Technology, and it's actually test data to run a 10th degree polynomial on with linear regression. But and actually I did that, and we may down here, if you can see all this down here, these are a bunch of sheets where I actually tried to fit some different polynomials to the data, but that's not what I'm interested in right now. So notice the data. Here's y is in the first column, x is in the second column, and what I'd like to do is get a nice plot of the data and then look at fitting a function to it. And so my first problem, right, is that the x and y are in the wrong order for usual sorts of things. And well, so I'm going to just highlight that whole column. I did a left click on that whole thing, and I'm going to say cut, and come over here and say paste. And now I've got it in the right order. Okay, and I could delete this column, but actually I'm going to need it in a moment, because what I want to do is I want to put this into Sage and use its data fit, and we'll see why. Because first I will put it into Desmos. Now, to put it in a Desmos, you don't want the x and y tops there. You just want to highlight your two columns. I got them in the right order. Okay, so I highlight everything. I do a copy. And then I come to Desmos, and so here's an empty Desmos. I can make it show up a little better in projector mode. And all I have to do is click in here, and now to say paste I need to use Control V. You can't do it with the mouse, right? If I do this, it's all the HTML stuff. So Control V, and it just does it. There it is, and there the data looks pretty nondescript at this point. You can zoom in on it, and I have another Desmos where I've already worked on this thing, but I can go here and mess with the y-axis here. Everything's greater than 0 on this, so I'll put in like maybe minus 0.1 and maybe even 0.01. But we'll just go up to like 0.9. No, not high enough. I mean, 2, yeah, not high enough, so 1. And here, maybe I want to start that at 0.5 or, not minus 0.5, plus 0.5. Something like that. Anyway, so I can begin to see the data a little better. Now, as I look at this, actually, I don't see a 10th degree polynomial. I see something. Oops. As I go along here, it looks kind of like an S curve, and we'll see plenty of S curve in our first. Well, actually, I guess it doesn't make the S yet. In our first project, it actually is just down here in this part. But it looks like an S curve to me, and a good way to make an S curve is e to the x, and then divided by 1 plus e to the x. And I can't see it here, but if I zoom out a bit, you can see it. So you see that sigmoid curve, an S-shaped curve, sigmoid, is kind of what I see there. So that's what I'd like to work with. And I want to use my 4 parameters to, for instance, move this center point here that's right now at 0.5 to right there. Okay, so around minus 6.6 and 0.832, somewhere in there. I want to move. So I want to move to the left by a little more than 6.5, and I want to move up by a little more than 0.3, maybe, is what I think. And then I also want to kind of either stretch it or compress it or something along those lines. But from this center point of the S, I can kind of tell where I might want it. And but I want to get Sage to do that for me. And so in order to get Sage to do that, I have to get the data ready. And so the data, if I come back here, the data need to look something like this. I think I need a square bracket to start with. Well, let me get rid of that and come up here, and I can make this a little bigger, so you can see what's going on. But what I need is something like a square bracket like that, open parenthesis, and then my x1, y1 point like that, comma, and then x2, y2, and so forth until I'm done, and then a closing square bracket. Okay, well, I don't have that, and but I could get what you can do is you can use what spreadsheets are really good at, which is repetition. So I'm going to put a open parenthesis there for this whole thing, and then copy it down. I can do that by a copy paste. I can grab this little box here, pull it down, or I can double click on that and it will fill it all the way down to the bottom. Okay, so filled it all the way down to the bottom. And now on this first one, I actually need that square bracket to start with. Then here on this side, I need the closing parenthesis and a comma. And so then I can do the same thing here, double click, and it does that all the way down. But this one I need to fix up to be a square bracket. Now the only thing I'm lacking is a comma on the inside, so I can go in here and insert columns left, put a comma, enter, and do that all the way down, and there you have it. Now I could copy all this and try to work with it that way, but try it in things, and it adds a lot of tabs and so forth, and so that's no good. I don't like that. But there is a concatenate command. So it's right there, concatenate, and open parenthesis, and what it does is it just separate by commas, what do I want to put together? Well, I want to put that, followed by that, followed by that, comma, followed by that, comma, followed by that, and close that and hit enter, and there you go. There are my numbers, and if I double click on that all the way down, now I was right next to E here, so it knew what to do, and so there I have all my numbers. And what I can do is then, well, I probably shouldn't have clicked on that because it was already highlighted. I need to highlight this whole thing and copy it. And then I need to go to Sage And if I go to Sage Cell Server, notice, see here I said data equals, and then I just pasted. And notice it goes down here, and there are all my data, and it stops there. And then I use, let me make this bigger so you can see better. Do it again. Okay, and so again, I just said data equals, and then I pasted, and that whole column pasted in here. Sage says that's fine. And then I said show the data. And as you look here, there's the data being shown. Then I needed to declare my model pieces. And so my, my symbolic variable x, but then I had my parameters a, b, c, and d. And b is usually what you multiply your function by. So I have the b there, a times the x stuff on the inside. So the b is on the outside, the a is multiplying on the inside, and I have my minus c and the plus d on the outside. Now, what I could have done was I could have instead said, oh, let's say that f of x is equal to my e to the x divided by, and then parenthesis 1 plus e to the x. And I believe this will work. And so this might make it a little more obvious what I'm doing. And then for my model, I could say, oh, well, what I want are those 4 parameters. So a times f of b times x minus c, close parenthesis, and plus d. I think that will work, a model of x here. And I haven't tried this before, so I'll try that. But you see here it makes it very clear that my base model is that sigmoid e to the x over 1 plus e to the x, and then I'm going to have this model fit the a times b and so forth. And excuse me. Then I have my solution equal, and there's this nifty Sage thing called find fit, and you give it the data and the model you want to fit. And so I do that, and then I say show that solution. And here I have some things commented out. We'll see why in a minute, but here's where I showed the solution. And we'll see if I get that same solution. So A was about 5.14, B 26.6. So let's try to remember that, and we'll try this. And then I go down here and plot it. We'll look at that in a minute. Let me hit evaluate. Let's see if this works. Okay, yes, very happy. It comes up with A, B, C, and D here. And yeah, that's what it did before. So this blue line here is the model fit that it came up with. I would say not good, right? It failed. And this is why you want to know sort of what this is trying to do and what these 4 parameters do. Because this failed miserably, and I haven't worked with it a lot to try to figure out, how I can fix that. Now it's interesting. Here's how miserably it failed. What I did the first time I did this was I showed the solution, and then I went in here and I highlighted that. Okay, and I did a Control C, and Yeah, well, I was trying to do it with the mouse. It won't do that, just like Desmos. So I did a Control C, and then I came up here and I said, okay, now for this F, ooh, that's probably not good. You know, probably going here, and I'm going to do a G and a G. I'm not sure what that would have. It might have gotten confused, but I kind of doubt it, but it might have. I'll hit evaluate just to make sure here. But notice it's interesting. I get these same numbers, but the A and the B are actually switched here. C is the same, and the D I think is the same. D 0.8, yeah, 4, yeah. So I don't know what happened with the A and the B. Maybe it doesn't matter if they get switched. I don't know. I didn't look that closely at it. A, B's on the end. No, it would matter. So at any rate, but neither one of those solutions works. Okay, but I had just come up here. You know, I had highlighted that, copied it, and then I did this substitute command where I said, okay, F, not the f of x I had here, but just a new f is equal to the model. Okay, the model with these substitutions, so dot subs, and I told it what to substitute. And now, but the thing is the way it created the solution, actually I could get that. I could get A equals, well, this says 5, but now it's 26. I could get the A equals 26 simply by saying take solution and of index 0. So that was this part, and then comma, here's the part with index 1 and the part with index 2 and so forth. So I just did that for the substitution, and because the index 0 part was A equal 26.6, well, I got that substitution, so I could do that just fine that way. So that's a little bit more automatic way. I didn't have to copy and paste, and so I didn't really need that. And here I show f, and so there's the function, and then I do a plot. And now notice this plot. P is the plot, but I plot f from -10 to 0, and then I add to that. Now, adding of two plots just superimposes one on the other, and then a list plot is what it's called, list underscore plot of the data. Okay, so that's a nice thing Sage can do, and I show those, and of course I see how badly it did. Okay, well, so it failed. And I don't know, there's a darn thing I can do about it to get it to work. You know, it failed. It couldn't do it. But I can do it. Okay, I can do a pretty good job. So, you know, I come back here, I start with this basic idea, and again, you know, here oops, that's the wrong thing. Here we go. Here I show that g of x again, but I went ahead and I did it this way: f of x with the b out here and the a times x minus c, a times x minus c plus d. I wrote it out that way, but again, I could have written it as f of x equals b times g. Oh, I see. Oh, I do. I have the A's and the B's backwards. That's why this changed in here. Okay, I hadn't noticed that. I guess I had screwed that up, right? I had had the B on the outside and the A on the inside. Silly me. Okay, so so we come back here and we look at this. So I'm gonna fix this. And now notice I gotta look at my numbers here. This is 0.153 and 2.9. So this is going to throw this out of whack when I make that an A. this a B, and that a B, as it should have been. And, again, I could have, I could say F1 here and of X, and that equals A G of B times X minus C, close parentheses, plus D. Now, it doesn't look very good, but that's because I have my A and B backward here. So 0.153 and 2.9. And that's looking pretty good there. We'll zoom in on it here in a moment. And if I do the other F, so the red F, it's same function, right? So I could do it this way or that way. Now, so what I did was, I started with that, and then I messed with this, and what I found was I had to, it asked me when I put this in, do I want to make sliders out of these A, B, C, and D? And I said yes, and so it defaulted between 0 and 10 like this B is here. And that worked fine for the B constant, but some of these others, right, C needed to be -6 because I needed to move to the left, and so I could go in and what I noticed was I wanted to be able to move that slider but not change things a whole lot. So notice here, if I move the slider, well, we'll zoom in on it. Okay, so I zoomed in on the data and I moved that slider around, and I just eyeballed it, and I kind of went, I got in here and I kept looking at it, and there's, 3 looks pretty good. I don't see a problem with 3. But for whatever reason, I ended up going 2.9. Now that, you definitely want to not have that between 0 and 6 because, it ended up being down here about 0.15. And as I moved it, notice by the time I'm at 0.8, it's way off and down to 0 and so forth. So, what I did was I came in here and I made this like 0.2, and that way when I messed with the slider, I could get it more where I wanted it, and I think I have that 5.3, I think. But you see it's very sensitive to movement on there. And if you have dexterity issues like me, well, you can just, do something like that. Change it that way. Just by plotting it there. But you see, I just kept moving it around until I got it in the right place. D moved it up and down, right? That moves it up and down, and I think that was 767. Where I had that, that moves it up and down, and that ended up fitting the data pretty well, except for this part in here. And but I'm quite happy with that fit here. Now, what I could do is make a piecewise function. I could say, oh yeah, this is f of x. We'll do the red one. Get rid of the g there. It's f of x from whatever this is, somewhere near -9, I think, over to around -6, and then that looks pretty linear there. Well, I even eyeballed that, and there I just, I messed with the slope, and I messed with a center point, or a point and a slope. I don't know if it was quite the center point or what did I use here. X was -4.8, So yeah, I kind of came in here near the center of this thing, I guess, and used a point there, and then the slope, and and I just kind of messed with that until I thought, oh yeah, that looks pretty good, right? And what I could do is decide where these cross. I could come up with that intersection there and make my piecewise function based on that x of minus 6.214. So, what are the morals here? One is, well, A, B, C, and D, they allow me to take a basic function like this one and morph it, right? Transform it into what I need. I can do some very simple things with it. I can move it side to side, up and down. That got me the center where I wanted it here. And I can make it taller by stretching or shorter by compressing it. And what I do here, so B is on the inside. So actually I compressed it in both directions. So on the outside I used 0.153, so I had to compress it because that's less than, A is less than 1. And on the inside B is greater than 1, which also means I compressed it. I made it a steeper slope here by compressing it. And I got a pretty good picture. And then, well, depending on what I'm doing and so forth, I might say, well, yeah, something happened in here, and this we actually will see on the project, is, something happened in here that made this linear all of a sudden, but, it started out as this more sigmoid kind of curve, and then we had something happen in the model that turned it into a linear case, but I can just eyeball it. I can get it that way. And if I come back here to the Sage cell, now I gotta fix this up as well, because yes, I see here that I had the A and the B in the wrong place. So there's an A, there's a B. I don't know why I did that, but won't be the last time I screw up. So so we have the A usually on the outside, B's on the inside, and so forth. So here, let me swap my A's and B's. I can do it as simply as saying that's B and that's A. Okay, so if I substitute these numbers that I got from eyeballing it in here, so I'll uncomment that and put a comment here. Just use the pound sign or hashtag to make a comment. I can evaluate, and so I don't use any of that fancy data fitting stuff that they had, and there's my nice picture of the data. And so sometimes when you're trying to fit data, if you're fitting it to I guess a complicated enough problem, so this was complicated enough, software might not do the job, and and so you have to eyeball it, and it's not perfect. You might come up with slightly different constants, and again, instead of 2.9, you might have come up with 3.0 or something like that, or 0.152 instead of 0.153. But we got it pretty close. And we did that using the for function thing, and Sage died on trying to do it. Right? It was a complete and utter failure. Sage and the programs it runs behind the scenes are great. They're fantastic. But unfortunately, technology can't solve all your problems. And so you actually have to have some idea of what the heck it is you're trying to do. And so here is a case where using those 4 parameters, we could get a pretty nice fit here. Whoops, wrong one, that one. That's where I actually have the fit. Get a pretty nice fit. And then we can even throw in our piecewise function here with the sigmoidal part until we get to here, and then go with the linear part for the rest of it. Okie doke. So there's an application to some real life data in the sense that, you know, it's from the National Institute of Standards and Technology for checking things. But in the end, I don't think it comes from like a study or, you know, looking at people doing something or anything like that. I think it's just their test data for a particular standard that they're trying to reach. Okay, so we'll call that good for this video.